Hello everyone and welcome. This is the first ever video that I've recorded using my new/old setup. New in the sense that I got some new equipment, old in the sense that I used to do videos just like this way back in the day. So I thought we'd start with something simple, just a little equation, a little chemical equation, and we're going to balance this sucker. So the equation is we have elemental manganese reacting with hydrogen iodide or hydroiodic acid, whichever you prefer, to produce elemental hydrogen, H2, and manganese 3 iodide. So the way that we're going to do this is we're going to balance one element at a time, keeping a running count of how many atoms of every element that we have, both on the reactant side of the equation and the product side of the equation. So I got my little table here with manganese, hydrogen, and iodide, a column for the reactants and a column for the products. So let's get started. So the way that I like to start these off is by simply assigning a coefficient of 0 to every chemical species in the equation. So the implication there is that so far we haven't assigned any coefficients, and therefore we have 0 atoms of every element in this equation. The next thing that we're going to do is we're going to choose which element we want to start balancing. And remember, whenever you choose which element you want to start with, you want to go with an element that appears only once on both sides of the equation. In this case, all three elements, manganese, hydrogen, iodine, apply. They all appear only once on both sides of the equation. So really it's just a dealer's choice, whichever element you want to start with. I think I'm going to start with iodine. So if I locate the two chemical species that contain iodine, we have hydrogen iodide on the left, on the left, and then we have manganese 3 iodide on the right. Of those two, I'm going to identify which one has the most iodine atoms in it. Hydrogen iodide only has 1, while manganese 3 iodide has 3. So I'm going to take that species that has the most number of iodines, and I'm going to give it a coefficient of 1. In giving the manganese 3 iodide a coefficient of 1, we've changed the number of manganese atoms and the number of iodine atoms on the right-hand side of the equation. We no longer have 0 manganese. We no longer have 0 iodine. And remember, in order to count the number of atoms, what we do is we take the coefficient in front of the compound and we multiply it by the subscript following the element. In the case of manganese, we've got the coefficient of 1 multiplied by the understood subscript of 1, giving us 1 manganese atom. Taking the same approach with iodine is 1 times 3, or 3 iodine atom. So we have 1 manganese atom and 3 iodine atoms on the right. Next, what we're going to do is we're going to balance iodine by placing a coefficient in front of this hydrogen iodide that gives us 3 iodine atoms. So again, we have an understood subscript of 1 in this HI compound, right? So we need a number that, when multiplied by this understood subscript of 1, gives us 3. In this case, it's pretty easy. It's simply going to be a 3. So since we've assigned a coefficient of 3 to this guy, that changes the number of hydrogen and the number of iodine atoms on the left-hand side of the equation. So hydrogen, we have 3 now, because 3 times the understood 1 is 3. And the same is true for iodine. We have 3 iodine atoms in the reactants. Since the number of iodine atoms in the reactants and products match, we've successfully balanced iodine. Congratulations to us. Okay, so hydrogen at this point looks like it's going to be a little tricky, so I think I'm going to save that one for last. So let's go ahead and balance manganese. So looking back at the right-hand side of the equation, we have 1 manganese atom. On the left-hand side, we don't have any yet because we haven't assigned any coefficients here, but this one is pretty straightforward. It looks to me like the only coefficient that we need to put in front of here is simply a 1. Make that a little bolder for you. So we've just changed the number of manganese atoms on the left-hand side of the equation to 1. And since these match, you guessed it, manganese has successfully been balanced. So here comes the tricky part, and this is where I want to act pretty slowly and deliberately to walk you through how this works, right? So we have 3 hydrogen atoms over here on the left-hand side of the equation. We need 3 hydrogen atoms over here on the right-hand side of the equation. And notice the subscript following that hydrogen is 2. So we need a coefficient which will be a number that, when multiplied by 2, gives us 3 hydrogen atoms. Let me say that one more time. A coefficient that, when multiplied by 2, gives us 3. That sounds an awful lot like an algebraic equation to me. So let's go ahead and say it one more time, setting it up as an algebraic equation. So we need a coefficient, which I'll call x, that when multiplied by the subscript 2 is equal to 3. Now if we take this equation, solve for x, pretty simple. All we have to do is divide both sides of this equation by the number 2, and we get x is equal to 3 halves. So that makes our coefficient 3 halves. And that makes the number of hydrogens on the right-hand side of the equation 3. If we take 3 halves, the coefficient, and multiply it by 2, the subscript, those 2's are going to cancel out, and we'll end up with 3. So hydrogen has now been successfully balanced. Now, depending on what kind of teacher you have, some teachers are perfectly fine with their students leaving an equation just like this with a fractional coefficient. Other teachers do not accept fractional coefficients and will require you to get rid of the fraction and have whole numbers for all of the coefficients. So I'll go ahead and show you how to do that. It's pretty straightforward. All that we need to do in order to get rid of this fraction and have whole numbers all around is to take the entire equation, right? Take that entire equation and multiply it by the denominator of the fraction, which in this case is 2. So we're multiplying that whole equation by 2, which means we multiply each of these 4 coefficients by 2. So let's go ahead and do that. For the manganese, 2 times 1 is going to be 2. For the hydroiodic acid, 3 times 2 is going to become 6. For the hydrogen, that's pretty easy. 3 halves times 2. 2's cancel, and we get 3. And for the manganese 3 iodide, it's going to be 2 times 1, which is equal to 2. So now this equation is not only balanced, but it's balanced with whole number coefficients. And since we've multiplied everything by 2, all of the atoms in this table are going to be multiplied by 2. So manganese goes from 1 to 2, and both the hydrogen and the iodine, they were 3 before, but since we multiply it by 2, they all become 6. All right, so I hope this video was helpful. If you'd like to see more videos like this, please let me know. Thank you very much for watching. Feel free to drop a like on the video if you think it's well deserved, and don't forget to subscribe, turn those notifications on so you'll be notified the instant my next video is uploaded. Thanks again, and take care. Bye.